Now we're going to discuss piecewise defined functions. This is a special category of functions that comes up a lot in advanced math. And what's kind of unusual is there isn't just one formula that describes them. We actually use formulas from different functions, you might say, and we take pieces of different functions to put together a new function. So we're going to go right ahead and start exercise 12 here on our handout that I've transcribed onto a sheet of graph paper. So here it is. And so we're looking at this new kind of notation. F of x equals brace, and then there's two lines. X plus 6, x less than or equal to negative 2, x squared, x greater than negative 2. So the first thing we want to do is learn how to read this notation. So let's just try to write out some function values. And maybe before we write out the function values, I'll talk a little bit more about what this notation means. So what this is saying is that for certain values of x, we plug into x plus 6, and for other values of x, we plug into x squared. So we might say the following. We might say f of x is equal to x plus 6 when x is less than or equal to negative 2. And f of x, the same function, is equal to x squared when x is greater than negative 2. So this is where this idea of piecewise comes in. We have different pieces of this function for different situations. Now let's go ahead and evaluate f of 3. Well, when you evaluate the function, you got to decide, do I use, f of x equals x plus 6 or f of x equals x squared? And that depends on the value of x that you have. 3 is actually, it's greater than negative 2. So I use the lower formula here. I'm going to plug into x squared. I'm going to just take 3 squared. So f of 3 is 9. If I wanted to compute f of negative 3, our second value we want, well, when x is equal to negative 3, that's actually not greater than negative 2. It's less than negative 2, right? So it falls into the category less than or equal to negative 2. So I use this formula for the function x plus 6, which would mean I take negative 3 plus 6, which is 3. And we got one more we want to calculate here, right? We want f of 2, or f of negative 2, sorry. F of negative 2 is, well, it's not greater than negative 2. It is less than or equal to negative 2. It's equal, so we use the upper qualifying inequality here. And so we're going to use the x plus 6 formula. We're going to plug into that. Negative 2 plus 6 is 4. So these are the y values that correspond to the given x values. Part B, what is the domain of this function? I guess I can leave it like that. If you look at these defining inequalities, it almost looks like we have certain intervals involved, right? I'm going to mark negative 2 on a number line. So we use one formula when x is less than or equal to negative 2, equal to negative 2, or less. We use the other formula when x is not equal to negative 2, but just greater than negative 2. So for all values of x, though, this function is defined, so the domain is all real numbers, which in interval notation we write as minus infinity to infinity in parentheses. Now let's go ahead and sketch a graph of this function. And the idea is it's going to be a piece of f of x equals x plus 6 and a piece of f of x equals x squared. Instead of writing f of x, I'm just going to write y equals a couple times here. It's a little bit easier to talk about in that way. So we're going to take a piece of y equals x plus 6. And we're also going to take a piece of y equals x squared. And I'll call this is the preliminaries. So I'm not drawing my graph right away. I want to do a little bit of background. And I think once you get the hang of it, you'll be able to jump right to the final graph. But to see what's going on here, I think it's a little bit helpful to break this down into a few steps. So what we're going to do is first, we're going to use that one defining equation piece, y equals x plus 6. Let's go ahead and graph that. Now, it has y-intercept 6, and it's got slope 1, it's got x-intercept negative 6. So you can plot whatever points you want. I'm going to draw this line in pencil first of all. All right, so I'm trying to line things up here. Okay, so that's just a straight line graph. And now I'm not going to use all of this straight line. This is where those conditions come into play. I want to only use f of x equals x plus 6 when x is less than or equal to negative 2. So let's actually write x less than or equal to negative 2 here. Negative 2 is right here on the x-axis. The point that corresponds to it is right here. That's negative 2, 4. When x is less than negative 2, I get points along here on the line. So I only want to work with the piece of the line from this point at 2, 4 to the left. So we're only going to use the piece of that straight line that I colored in blue. Now we're going to do a similar thing with the y equals x squared. If we go back to our defining relationship for the function, we use f of x equals x squared when x is greater than negative 2. Let me just write x greater than negative 2 below. And so this f of x equals x squared, I just rewrote below here as y equals x squared. And we've seen that graph a lot, so I'm going to sketch it really quickly. It's got 0, 0, 1, 1. 2 squared is 4. 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1 squared is positive 1. Negative 2 squared is positive 2. And we get a parabola. Let's see. Whoops, I put my negative 2 in the wrong place. There we go. Negative 2, 4 is here. This is negative 3, 5, 6, 7, 8, 9, way up there. I don't have an eraser handy. I got that baby. Let's do that. All right, so we know our y equals x squared graph. But now we only want to consider the portion of this graph when x is greater than negative 2. So certainly for negative 1, 0, 1, 2, 4, 3, 9, we want this piece here. But what's maybe a little bit subtle is in between negative 2 and negative 1, we really want that portion of the graph too, because numbers between negative 2 and negative 1 are greater than negative 2. So we want a piece of the graph over here. How do we draw this? Well, the easiest way to do it is to go up to that point at negative 2, 4. We're going to put an open circle there. And draw the graph to the right of that. So we're taking that blue portion of the graph. And now I'm going to put these two pieces together, and that's going to give us our final graph. If I draw this blue portion and this blue portion on the same coordinate grid, that's going to give me my final graph. And I'm just setting up a coordinate system here. Okay, so I'm going to draw the final graph right here on this grid. Sorry, went off the screen. So first I want to draw this portion of y equals x plus 6 from negative 2, 4, negative 2, 4. And I want to go down to the left, right? So it's got slope 1. It's going to cross the x-axis at negative 6. And let me use my ruler. And then to this picture, I want to add the blue portion of the y equals x squared graph that we drew. So I need some points from that graph. Negative 1, 0, 1, 2, 4, 3, 5, 6, 7, 8, 9. Now I don't want to go too far to the left. This open circle is actually at the point negative 2, 4. The open circle coincides with this point that I already have. Now I don't place an open circle over it because remember this is a graph of the final function, and the final function has the point negative 2, 4 on it. That's defined by the x plus 6. So we're just going to connect up our parabola like so. And here's our final graph. A little sloppy. So there's the final graph of this piecewise function. That's a piece of a straight line, y equals x plus 6, and a piece of a parabola, y equals x squared, stuck together. And just notice from the way we drew the graph, if we interpreted the domain graphically here, we would get again that the domain is all real numbers, which we already observed in part B of the exercise. Now the next two examples are very important, so be sure to check out both of those.